Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, in today's lesson, we continue with vectors. Then we'll look a bit into sets and see how we move on from there. So we continue with question 9. And basically, question 9 says, in a rectangle OPQR, OA is equals to A. So let me just, we can draw this rectangle quickly here. Okay, so this is a rectangle like that. So just a quick rectangle. And draw a rectangle like that. Okay, this is our simple rectangle. Okay, then we have rectangle O P Q R OA is equals to A. Okay, OA. I think this question might have made a mistake, and the rectangle is the one that is down here. So this is supposed to be in a rectangle. Let's see, in a rectangle A, the O A B C. Okay, not this. So it's supposed to be in a rectangle O A B C. OA is equals to A, so OA is A. OC is C. M is the midpoint of AB, and N is the midpoint of BC. ON meets this ON meets MC at P. Find the expression for the following terms in terms of. So this is basically a grade 12 question. So I'm going to leave you to try this one out. Then we'll see how we move from there. So this is a triangle, not OPQR. This is the triangle OABC. Okay, so make that correction on your paper. Then find ON, find MC, express OP in terms of ON, and also OM plus AM plus NP. Hence find the missing values. Show that the ratio of OP and PN is 4:1. Yeah, so this is basically easy. So you just find OP and you find OM, then you ratio them out. So they should give you a 4:1 ratio. So, but basically what I can just give you in this lesson is a reminder of what you already know. So for instance, if you have a triangle like that, you have a triangle, let's say that's a triangle, and you have A, B, and C. Okay, and this is a direction. Let's say this is A, and that is B. Okay, so that is B. So what I can just remind you is if you are looking for, let's say, AC, okay, so AC, we have CA, which is showing this direction here. So AC will be equals to from A going to C. Okay, from A going to C, we have that vector. So that will be, since we're in the opposite direction, that will be negative A. Okay, suppose we're looking for, let's say, CB. Okay, CB, there is no vector here. So we need to move from point C, going round, covering some areas. So we need to cover 3 points for us to get to B. So that is CA. So that is CA plus AB plus AB plus AB. So we need to cover 3 points. Basically, the reason why we cover 3 points or 2 points is because this is vector addition. Okay, and I'll explain that more later. Yeah, so that is then you replace CA. What is CA? So CA is positive A, because C going to A, we are moving with the positive, so that will be positive A, plus AB. AB, we are going against this arrow, so that will be negative. Okay, so that is negative B. Okay, and basically CB will be equals to A minus B. Okay, this is just a quick reminder of what you did in grade 12. So, but yeah, I think what I can also talk about, let's say, so this is how you're going to find these, then express OP in terms of ON, and also OM plus AM is equals to MP. So what they want you to find here is just OP. So find OP in terms of ON. Okay, so OP, basically there is no OP. That is, this should be OA. Express OA in terms of ON. Is it like that? Let me just, which one should be? The problem is the question had an error. So let me just, OP is here. So OP is here from here to here. So express OP in terms of ON. So you find OP, how is OP going to be in terms of ON? Where is ON? Okay, so here meaning you need to use the ratios that you've been given. So OP in ratios, what is it equal to? Okay, so let me just talk about ratios a bit. So let's say this, let me see, find the, okay, if this is a, this is, this has, let's say this has a ratio of, let me just do this. Say there is a point here. There is a point here. So suppose there is a point here, M, okay, and you're asked to find CM, okay, and maybe this has a ratio of 3 to 1, okay, or maybe they just say this has a ratio of 3 to 1, meaning that for you to find CM, you need to consider the ratio of CM, which is 3, and the total length. So this is from here to here, that is 3/4. You add 3 plus 1, so which is over 4 of CB. Okay, so that is how you consider ratios. So CM, which is just this, which has a ratio of 3, you say all over the total length, which is when you want to use B. So the total length there is 4, then times BC. So this will give you the ratio like that. Same applies if you're looking for MB. Okay, MB, meaning that the ratio there is 1 of the total length, which is 4, then of CB. Okay, CB, like that. So that is the ratios that we're doing here. So even here, OP, which is just this length, will be ratioed like that. So OP, and they just want you to write an expression. They don't want you to write the answer. OP is a ratio of, did they put anything on ratios here? So they said, okay, so basically what you can do here is you're going to put arbitrary values as your ratio. So maybe this as, let's say OP and ON have ratios of, maybe this is K to N. Okay, so you don't know the ratios. So OP and ON have ratios N to K, N to K. So you are going to use the same logic. So that is OP is basically equal to N over N plus K, N plus K times times ON times ON. So ON will be found here. So you use the ON that you find here. Then you basically simplify that. So that will be the solution for here. Then you're also asked to find also OM plus AM plus MP. So OM, which is you find OM. After you find OM, you add to AM. After you find AM, you add to MP. Okay, so this is what you're asked to find here. Hence, find the missing values. So now here, you are asked to find the missing values. This is the N and the K. So I just want to see how you fare with these questions. Then I'll come in later like that. Then from there, we move on. So, but let's do a little bit of sets. Then so you have this task. So try your best. Then we'll see how we'll move on from there. Now, under sets, I think number of elements NA, number of elements in A is 15, number of elements in B is 20, number of elements in A intersection B is 9. Find number of elements in A union B. So A union B, you just say this number of elements in A union B. You know that A union B is equals to, so you have number of elements there. So this is equals to number of elements. Your A union B is equals to A plus B minus A intersection B. Okay, so that is how you find A union B. A plus B minus A intersection B. So you distribute this number of elements. That will be number of elements in A plus number of elements in B minus number of elements in A intersection B, like that. So this basically comes from set theory. So for instance, if you have a set A there and a set B, A, B, so when you count the elements of A, you are counting the elements of the intersection plus the elements of B, meaning that you've counted the intersection 2 times. So you subtract from the intersection there. So what you should know is that so hope you've copied that. So, but what you should know is that A union B is basically equal to A plus B minus A intersection B. Okay. Then what you'll be doing for number of elements, meaning that you're putting number of elements in front of these, in front of that. Okay. You can make A intersection B subject of a formula. You can make a B subject of a formula, and so on and so forth. So that is how you're going to approach this question. So I've given you the formula. You can work that one out. Then we come to question 2. Question 2, a set Q has 256 subsets. How many elements are in the set? Okay, so you should know that 2n, 2 to the power n, 2 to the power n is equals to the number of subsets. Okay, so now you're looking for n here. So you have 2 to the power n, which is equals to 256. 256. So how are you going to find the value of n here? So this is a question for you. So finish that one out. Okay, before we come to this, since we are still on sets, let's jump this one. Then we come to intervals here. But for this one, you solve this question here. Okay, then question number 4. Question number 4, list the elements of the following. So what you should know is that if we have these signs, so let me see. Okay, if you have this and you have a number there, this means that we are starting from A. So that is A less than or equal to. Then we have an enclosure like that, then B this side, meaning that there is X, where is it? So there is X here. And since this is closing here, we are closing with a less than or equal to B. So these square brackets means less than or equal to. Okay. Then the parentheses, if you have A, comma B, this means A less than X less than B. And the two can be combined as you've seen in this question. So meaning that you can have a closed brackets there, A, then you have B, then like a parenthesis there. So this means that A is less than or equal to X, which is less than B. Okay, so this means less than. So the closing here means less than. So these are the intervals. So you try to solve these questions. So I just want to see your thinking process on these, then we'll move on from there. So try the questions. So these are the intervals. The square brackets means greater than or equal to, less than or equal to. So as you've seen here, so you are asked to list the elements in the following set. So you list these elements, then we'll see how we'll move on from there. Okay, so that is question number 4. So today you're going to have a lot of work. Then yeah, so just take your time, just think about how you can list the elements. So these are the intervals, meaning that here you're starting from point A. Okay, so here means that you're starting from point A. A is included in the list, then all the way to the number just before B. Here you're including point A and you're including point B. Here you're not including point A and you're not including point B. So numbers in between. So this is these signs here. Okay. X less than or equal to. Equal to mean that you're starting from that point. X less than or equal to B, meaning that X greater than or equal to A, meaning that you're starting from A all the way to X. Less than or equal to B, meaning that you are starting from B going down. X less than A, X less than B, meaning that you're starting from B, you are not including B, you're going down. X greater than A, meaning that you're not including A, you're going up. Okay, so these you try out these questions, you list the elements. Okay. Yes, so we'll see how I'm especially interested on how you list this one. Then if a set E is a set of whole numbers less than 15, set A is equals to this and set B is equals to that, list down the following sets: A union B complement, A intersection B complement. Okay, so you try out this question as well. Just want to see how you do it. So the universal set is a set of whole numbers less than 15, meaning that we have 1, 2, 3, all the way to 15. Okay. Find A union B complement, A intersection B complement. I think I can add more. You can also find, let's say 3 here, you find A complement. Then I also add 4. You find A union B. A union B. Also add 5. You find you find A intersection B. A intersection B. Okay, so these are the additional questions. From these, you find A complement, find A union B, and A intersection B. Okay, so that is question 5. Okay. Okay, so I think question 5, you can also do question number 7. So number of elements in L is equals to 20, number of elements in M is equals to this, number of elements in that is equals to that. find the number of elements in A intersection M complement. So that is outside M. What I should give you is, I think, axioms that you should know. The first one, of course, that we talked about is A union B, which is equal to A plus B minus A intersection B. The other one, maybe you have A complement. So this is equals to 1 over 1 minus A. Okay. Then, so this same applies when you're dealing with number of elements, you just include number of elements there. So also when you have A complement intersection B complement, so we can factor out the complement. So this becomes A, then this will change to a union B, then the complement comes out. Same applies if you want the complement to go inside, meaning that the sign will change to intersection, and this will be A complement intersection B complement. Okay, so these are some set theories. So this is also known as De Morgan's. Yes, so I think let me also talk about when you have A intersection B complement. Okay, let me just give you a visual presentation of this set. So that is when you have a set like that. So that is okay, A intersection B complement. B complement, it's outside B, so meaning that, and what is common with A, it is just the set A. If this is a set A and this is a set B, B complement is what is outside B, so outside B, and what is in common with A. So it will be just this set here. Okay, just this set here. Okay, so now if you check this set, basically this set is equal to A, the set A, minus the intersection here, minus A intersection B. Okay, so this is something that you can look at as you'll be working out other problems here. Okay, yeah. So basically question 7 is covered. I've explained how you look at it. So on this one, if you have, let's say, A union B, then complement. If you want to get rid of the complement, this is equals to 1 minus A union B. Okay, A union B complement is basically equals to 1 minus A union B. This is what this means. When you have something complement, this is just 1 minus that thing without the complement. Okay, so I think these questions are enough. Then we'll see how we'll move on from there. So yeah, so these are the questions that we're going to do. I'll be waiting for your response. Then we'll see how we'll move on from there.